Hello. As usual on weekdays, at this time we begin our Open Studio program. As usual, we welcome you live on the air in our open studio in the center of St. Petersburg. Today we chose a topic which has been passionately discussed over the past several days. I'd like to remind you that last week marked the final announcements of Nobel Prize laureates for this year. Laureates were declared in the fundamental sciences, in literature, the Peace Prize. The Chinese candidate for the Peace Prize has already provoked controversy, as you know. But today we're not interested in that. We're interested first and foremost in the Nobel Prize in Physics because, as you know, a certain scandal has erupted about the eligibility of the two formerly Russian candidates, who are now citizens of another country, now working in Manchester, to receive the prize. They are Konstantin Novoselov and Andrei Gaim. They became laureates of the Nobel Prize in Physics. The question is their eligibility to receive the Nobel Prize because the famous inventor and famous person Viktor Ivanovich Petrik claims that he was the first to discover graphene, a certain substance, and that the prize was given to Novoselov and Gaim undeservedly. This is a complicated issue, and today we will spend the whole hour discussing it, and additionally, we'll learn just what graphene is. I'll give you the thesis questions that interest us. We're interested first of all in the criteria whereby Nobel laureates are chosen. Second, on what basis are candidates included in the list of laureates? Do they prove or not prove, discuss or not discuss the right of priority, of first discovery, of authorship of inventions evaluated for the Nobel Prize? And in general, what is happening in science in Russia today? The subject is very serious. Allow me right away to introduce our guests. I'll tell you straight out that we have many guests, both in Petersburg and in our Moscow studio, and our guests will even change over the course of the program. That's why I'll introduce you right away. First, I'll introduce our guests in the open studio in Petersburg. Viktor Ivanovich Petrik, Doctor of Technical Sciences, Academician of the Russian Academy of Natural Sciences. Good evening, Viktor Ivanovich. Good evening. He's our hero of the day, the main man in this issue. Thank you for coming all this way, and if you'll allow me, I'll present our other guests in our open studio in Petersburg. Evgeny Nikolaevich Fursi, Vice President of the Russian Academy of Natural Sciences, Chairman of that Academy's Petersburg branch, Professor and Doctor of Physical and Mathematical Sciences. Good evening. Now I'll introduce our Moscow team in our open studio in Moscow. First, Vyacheslav Alexandrovich Sulin, Director of the Institute of Microelectronics and High Purity Materials at the Russian Academy of Sciences, Doctor of Physical and Mathematical Sciences. Good evening, Vyacheslav Alexandrovich. Good evening. And now a guest in Moscow, Vladimir Fyodorovich Razumov, Chairman of the Scientific Center of the Russian Academy of Sciences in Chernogolovka, Associate Member of the Russian Academy of Sciences. Good evening, Vladimir Fyodorovich. Hello, glad to see you. And another guest in Moscow, Professor Valery Timofeyevich Dolgopolov, Laboratory Head of the Institute of Hard Body Physics at the Russian Academy of Sciences and Doctor of Physical and Mathematical Sciences. I welcome you as well, Valery Timofeyevich. Thank you very much. Hello. Thank all of you gentlemen for coming. If I may, I'd like to briefly remind our viewers of the possibilities given by live television, that our phone lines are on, the forum has been online for a while now, and there are already many posts on it, among them ones passionately discussing the question that we'll be voting on today. And the question is simply this: do you think it's possible to give the Nobel Prize to someone who doesn't deserve it? For the third day in a row, yes has been in the lead. And here people have been mentioning Obama and Gorbachev and Solzhenitsyn and Brodsky. Basically, the list of controversial issues, according to our viewers, is enormous, and if we have time, we'll discuss it. But now let's get into our subject, and so as not to repeat certain details, let's watch a short clip with our correspondent Alexei Karsunsky and start the discussion. What's unique for the whole world is scandalous for Russia. Instead of eliciting pride for our forgotten fellow countrymen, the Nobel Prize awarded to Andrei Gaim and Konstantin Novoselov for the discovery of the unique material graphene sparked a scandal. The well-known inventor of water filters, Viktor Petrik, claimed that Novoselov and Gaim simply stole his invention from under his nose. It's work that was carried out in Russia, and we, the Russian Academy of Sciences and I, would have received that Nobel Prize long ago. but there's no way for me to break through to that, as you understand. Novoselov and Gaim also understood that there's no breaking through in Russia, which is why they left the country to work in England 2 decades ago, and in 2004 they made their discovery. A thing of genius, as usual, turned out to be simple. They separated fragments from a piece of graphite by means of everyday adhesive tape. Some plates turned out to have the width of a single atom, and these were graphene. It turned out that graphene has many useful qualities, unheard of endurance and good electroconductivity. All of this opens new possibilities for science and technology. Well, that means that computing machines will work much faster, even though they already work quickly, and that in super high-frequency technology we'll get closer to the terahertz spectrum, which is vitally necessary in customs when people are checked at security and for automated car control. We can go on infinitely, but there's one unifying characteristic in technology of the graphene era: more possibilities in smaller sizes. They say that an electronic newspaper as thick as a sheet of paper will cease to be science fiction, but we'll still have to wait for that, unlike the scandal and accusation of theft, which should be investigated with great rigor. I'll address myself to the forum right away. Viktor Ivanovich, you have first word, but first pay attention. I'll read 2 quotes first. First, of course, many people have only harsh words to say about you, but here there's a message from Tumin. Petrik, stay strong, overcome them, they're wrong, you just bet on the wrong country. But let's not talk about the country for now. But that's what people write, and I'm quoting them. If we can, let's hear it straight from your lips. What is your complaint to the Nobel Committee, in this case in physics? To the respected scientists from Moscow and to all countries, in my first words I'd like to say that this is a journalistic lie. I never claimed that I was robbed of the Nobel Prize. I never spoke those words. So that means that we came here today in vain? That was made up by journalists. My next move looks like this. In all of our newspapers and on television, 2 words are used: for the discovery and separation of graphene. I objected to that. First of all, graphenes cannot be discovered since we have always known about their existence. We always knew about the structure of graphite. Second, the Landau ban, the Landau-Pierre's limitation on the existence of separate graphene was lifted thanks to my work. For the first time, the possibility of graphene's existence was demonstrated. Moreover, from it we got nanotubes with open ends, the first in the world. From it we got the first in the world. Here you have a nanoring, here branching nanotubes. It's very beautiful. What you see are branching nanotubes, investigated at the Moscow Institute of Electronic Technology. So, Viktor Ivanovich, what is your complaint? I'll clarify how the prize given to Gaim and Novoselov was worded. For groundbreaking experiments regarding the 2-dimensional material graphene. You contest that they weren't the first? I'll repeat again. When we got graphene at the industrial level, I repeat, at my warehouse today there are 14 tons of material containing up to 30% graphene from which we got this. So the phrasing, first to separate, first to discover graphene, must be counted out, because that work is mine. In 2001, I received a diploma for the discovery, and in 2003, the American scientist Harries bought the right from me to publish these very separated carbonaceous carcass structures from graphene. There they are. So our proof is absolute. And as far as the investigation of graphene is concerned, then yes, unfortunately, we skipped that page. Nanotubes were in fashion. We were the first to get nanotubes with open ends. Graphene closes up, acquiring a more comfortable energy form. We got nanotubes. Prior to that, nanotubes had been grown from gas. They're closed on every side. So what was the mistake of the Nobel Committee? Let's get back to the Nobel. Nothing of the sort. I'm not thinking about any mistake. I consider, I repeat, the very same properties of the materials that the Institute of Electric Technology carried out, but with nanotubes. The next step with the product received was carried out, and I don't know that work. Last night I started studying it. If that work was noteworthy in any way, and I consider that there's nothing noteworthy there, then it's a traditional work with measurements of qualities. It's difficult to start the conversation here. Let's give the word to someone else. Yes, anyone? Moscow, please, go ahead. You understand this problem. I'd like to get involved here and say that unconditionally, Mr. Petrick is correct in saying that there's no scandal and no mistake. And the Nobel Prize was awarded absolutely deservedly. Besides that, in order for the general public to understand what we're talking about, we can take a look at a simple example that very closely matches the complaints of Mr. Petrick. It's well known that there's a small amount of gold in sand, but if anyone brings a sack of sand into a jewelry store and demands that he be paid for the gold contained in it, he won't be paid. Mr. Petrick is in that very same situation. He manufactures fine graphite products. There are graphite crystallites in it, and rolled up pieces and nanotubes, it's true, and plenty of other things. Among them graphene, possibly, maybe fullerenes too. But if he brings in that sack with that mixture and declares that graphene needs to be extracted from it, then that's a separate labor, and for that very reason that mixture can in no way be taken to be graphene. That's your point of view. What do you think? I think that that's not completely... First, I'd like to agree completely that that scandal was a fabricated affair. There's no such scandal, and the Nobel Committee is extremely qualified, and it's likewise meaningless to talk about any other Nobel laureates mentioned earlier, starting with Mikhail Sergeyevich Gorbachev. We, of course, can talk. Now, regarding graphenes. Yes, Viktor Ivanovich is absolutely correct that there's no discovery as such here. What's here is the question on how to get this graphene. I'd like to understand why this conversation arose in connection with Gaiman Novoselov in particular, during Nobel Week in particular. Because they recognize this wonderful material. They gave the Nobel Prize for it. Do you agree that the Nobel Prize should be given to Gaiman Novoselov? That was determined by the Nobel Committee. I think that this is the conversation we're having in Russia now, about the fact that many people also had success in that area. It's a productive conversation regardless of the awarding of the Nobel Prize. What Viktor Ivanovich did, as I am aware, was separate graphite layers via special technology, which is colossally industrializable. It's not the same as sticking tape and seeing one petal. Is it comparable to a sack of sand brought into a gold dealer's, as Valery Timofeyevich said? In order to get these formations, it was necessary to think hard and have gumption, and to come up with this technology that's strictly industrial. This technology is strictly industrial. It's not at all a sack of sand, from which it's utterly impossible to extract gold. You actually can, by enriching it and so on, but here it's much easier to extract it. I implore you, take a look. In 1998, the Institute of Criminalistics of the Federal Security Service of Russia showed in an electron microscope for the first time my findings. Next, processing these graphenes in special catalyzers, we got 90% different carcass forms, nanotubes, and so on. This is the Institute's conclusion. This is a homogeneous carbonaceous mass made up of flat elements of a graphite structure interconnected by van der Waals forces, graphite packets. Graphite, a piece of crystallic graphite. That's interconnected graphenes as we understand them. My dear sir, I made the discovery and you're telling me what graphite packets are. Let's take a look at the photographs of the graphenes of the Nobel laureates. They won't show them to you, but I'm asking them to. 3 days ago I sent them to America so that they'd be fresh. I have an enormous amount, but 3 days ago I received new pictures from the University of California. Let's show them. For the first time in the world, people will see what graphenes are. Go ahead, show us the pictures. I'm afraid that our guests in Moscow haven't said all that they wanted to say. Take a look, it's hard for me to comment on that. Vyacheslav Alexandrovich, maybe you can comment on it? Do you understand what we're watching now? What we're seeing? It's very similar to service pyrolytic graphite, and by that I mean crumpled sheets and nothing more. Sheets of what, I beg your pardon? We'd like to carry out this discussion professionally and politely. Professionally and politely, not the way the politicians do it. What are these sheets of? Let's see the second picture. Well, the question is how much carbon there is in each. Please, that's extremely specifically worded. Take a look. Right now you're seeing the image magnified 64,000 times, and then 120,000. I mean what you see now. Please make the next image fill the screen. Right now you're seeing precisely those very atomic layers, and there are probably more, about 200. And this is what Moscow University showed. Thank God they have. At the American ones, we start with 32,000 and finish with 250,000. Here we have a magnification of 5,000. But Chernogolovka gave the conclusion, the Academy of Sciences, at 3,000, and they said, we didn't find any graphenes. Kruglikov said that yesterday for the whole country to hear. How can you find graphenes at a magnification of 3,000? Tell me, I ask you. How could Kruglikov tell the whole country that there aren't any graphenes at a magnification of 3,000? Viktor Ivanovich, let's allow Vyacheslav Alexandrovich to state his position. Vyacheslav Alexandrovich, please give us your position briefly if you can. Well, I never heard Chernogolovka give such conclusions. But concerning those people who received the Nobel Prize, they prove that graphene is quite heavy with the help of an atomic strength microscope. And they demonstrated that the thickness of the object that they see corresponds to the monoatomic layer of graphite and to what's called graphene. But what we see in the picture, what scale is there, what thickness of the objects, I can't tell. Vyacheslav Fyodorovich, you are the chairman of the Scientific Center of Chernogolovka. Are you aware of any such investigations being carried out in the last few days? At Chernogolovka? No. We didn't carry any out. I'd like to shift our conversation to a different level. Let's clarify what the Nobel Prize was awarded for. Not for the discovery of graphene as such. Graphene itself, as a compositional part of graphite, that structure has been known for a long time, maybe even 100 years. But from the moment that X-ray structural analysis was discovered, we were able to establish the structure of graphite, that it really is made up of graphene sheets. Theoretically, the electronic properties of that material, had it been extracted, were already known long ago theoretically. I see. So what was the prize awarded for? The Nobel Prize was given for something else entirely. It was given not for the discovery of graphene, and not for its extraction or the technology used to extract it. The prize was given because the investigators were able to use it as a physical object and give us its characteristics and confirm what had been predicted earlier in the theory. And thanks to the fact that their work appeared, it was brought forward as an individual physical object. All of its properties were measured. Absolutely new quantum effects were found, and after that a large interest arose in science at large, and that's why the prize was given. Vladimir Fyodorovich, we need to break for commercials, so if you can shortly... When Nobel established his prize in his will, if I'm not mistaken, it says there that the prize is for an outstanding discovery in the field of physics, which means that the discovery of Gaiman and Vasilov can be called outstanding. Well, Valery Timofeyevich can tell you in greater detail, because we saw two-dimensional structure and its properties for the first time. How about this? We'll now take a commercial break and then continue. In a few minutes, don't change the channel. And we're back on there. I should tell you that during our commercial break, we called Manchester. Unfortunately, it's difficult for us to put it on air. We just asked Andrei Gaim a question about what he thinks. We recorded a segment. Let's listen to it. Please, if you'd be so kind, let us hear the recording. Come on, come on. Manchester's silent. Manchester? I'm a scientist, not a politician, and especially not a clown. To participate in the program with such an obvious clown and charlatan would be offensive to me. I don't want to bring myself down to that level. I think that a program on Martians and little green men would have a greater scientific basis and cause for interest than Citizen Petrick, who not only takes up state money, but your time and mine as well. I wish your program success, and that you not degrade yourself to the level of the yellow press. Best regards. Allow me to remind you that was Andrei Gaim from Manchester just a few minutes ago. Of course, I should tell Mr. Gaim in absentia that we ourselves decide who we invite to our show, and my crown won't fall from my head from discussing different topics, because it's important that we discuss those topics being discussed in society. But there's a certain hardiness in the Nobel laureate. I want to ask, there's one very important question. How do findings get to the Nobel Committee? Didn't you also have the right to go ahead and send them something and get word back? They would have considered you too. I quote from an article by Nevolin, who studied our findings. Wait a minute, about you and the Nobel Committee. Yes. Beginning in 1998, with the help of an atomic strength microscope, over the course of a year and a half, we observed completely free sheets with a width of 0.3 nanometers lying on electrodes. This again confirms a theoretically well-known fact that the slightest alteration from the graphene sheet theory must lead to a change in the flat surface. For example, folding into a scroll, as was once observed. I sent those findings to different countries. In France, they printed our findings. In each of our articles, 5 of them were written. It was stated that they had been extracted via cold destruction. Cold destruction because I don't heat the material. Novoselov took that literally, that it's necessary to extract them with adhesive tape, and he was the first to be heard by the world, but we weren't. Our findings about the existence of separate graphenes weren't looked at. There's a certain position in which that graphene exists. We took thousands of photographs in the University of California and in other universities, but they wrote tonight. We took thousands of photographs in the University of California and in other universities, but they wrote to nature. So they were heard, but you weren't. Then started an avalanche-like process. Every scientist started to study them by tearing them off and cited Novoselov and Gaim by the citation index. That's a formal sign by which the Nobel Committee gives its prize. But what did they measure? Show me their amazing findings. Vyacheslav Alexandrovich, do you agree that the citation index becomes the main basis for the Nobel Committee? They surely find it interesting to recognize famous people. That impact factor that characterizes people's work is one of the reasons for works to be considered for the Nobel Prize, but it's not the only one. And the system of nominations for the Nobel Prize is quite complex and not done that easily. So a person can't do it himself? Who presents things there? Scientific unions, academies of science, institutes, private individuals? Who? There is no application principle for the Nobel Prize. In reality, everything is done otherwise. Scientists publish articles that other scientists read. There's a certain number of people, probably a few thousand, to whom the Nobel Committee sends questionnaires. They don't know who exactly will be nominated. Those questionnaires are answered by experts. They say who they consider should be nominated for the Nobel Prize. And so they gather those several thousand questionnaires at the Nobel Committee, and then the Nobel Committee starts discussing which candidates there are. And then over the course of the discussion, the Swedish Academy of Sciences makes its decision. That's how it's done. Tell us, Vyacheslav Alexandrovich, again, independently of the situation we have here today, should the Nobel Committee busy itself with what's called the right of the first night? Is it its business to worry about who invented the radio, Popov or someone else? Who invented the light bulb? Is that the business of the Nobel Committee? No, that all concerns inventions. The Nobel Committee has no business with inventions. It occupies itself with scientific work. It has been that way for a long time. Mankind has been working on one form or another of appraisal work, and scientific work is a very specific field of activity. Nika, I'd like to shift our conversation to a different level. Let's hear what our specialist has to say about what this year's Nobel Prize was awarded for, the prize that we're discussing now. Valery Timofeyevich, please share a few words with us. Before anything else, I'd like to say that our program is gradually turning into a commercial for Mr. Petrick. That's no good. No, that's incorrect. Besides that, let's get to business. The Nobel Prize was awarded not for an outstanding discovery, but for an outstanding contribution to contemporary physics. That's the contribution made by Gaiman Novoselov, and I'm not even a fan of Gaiman. But I have no choice but to recognize that they made an outstanding contribution, because that's objective reality. What's the business here? It had been known for a long time that monolayer of graphite, these graphenes, should have completely unique physical properties. Moreover, some of these properties were determined 50 years ago. The radical step that was made by Gaiman Novoselov lies in the fact that they truly demonstrated the possibility of physically examining those monolayers as two-dimensional electronic systems, and became convinced that at least in part those unique properties exist in practice. And there is a hope that those unique properties that exist in other materials only at very low temperatures of helium, or not even helium, I mean 1 or 2 degrees Kelvin, can be transposed with the help of this very graphene into the area of relatively high temperatures, almost room temperature. And none of this has anything to do with Mr. Petrick. Nika, I'd like to add one very simple thing. What surprises me is something else, that these investigations were able to be carried out, do you know on what? On an everyday pencil. You take a pencil, slate, draw on paper, and there you'll have sheets of graphene. They're just small. They'll have the size of, oh, I don't know, maybe a few microns. That's not so. What you'll have there are graphite blocks. It's not so. Graphite blocks will be lying there. Separate atomic layers will never be lying there. Men of physics. Viktor Ivanovich, blocks as well. And what's next is that via simple technology, it was possible to extract those sheets of that size, so that simple electrophysical measurements could be done on them. That's all there is to it. Pardon me, may I ask you a question? Have you ever visually seen my technology? I'm ready to make a pile like this of graphenes right now. Yes, of course I've seen it, and more than once. I put it between the layers. We don't need an advertisement. Well, what do you care, Mr. Tulin? There's such a thing as a psychological definition of self-information through complicity. Right now, you're getting pleasure from the fact that these are your students. But we were the first to demonstrate the possibility of the existence of graphene outside a crystal lattice. Do you think that Gaiman and Novoselov are acquainted with your work? Yes, Novoselov ran around with my material. The cold destruction method was written about in our articles everywhere. He tried to find out what the technology was, and the most primitive way to do it is to tear it off with adhesive tape. So, Georgy Nikolaevich, the floor is yours. I feel that we should carry out our discussion somehow more scientifically and calmly. A few years ago, they accepted Furse's book in London. He's the author of a scientific discovery made in Soviet times that was carried out together with... They did it. It was just carried out. They made a cathode from our graphene. I haven't had a chance to speak. From the very beginning, I said that the Nobel Committee is the organization with the highest authority, and that it makes balanced decisions based on fully thought-through procedures, and so on and so on. That's not what's being discussed now, and it isn't commercial things that are being discussed now, but in Russia Mr. Petrik really did get graphenes and investigate them. Why cross that out? Wait a minute. What if instead of Viktor Ivanovich Petrik, who I understand provokes a certain reaction from all of you, a certain Mr. Smith sat here with the same claim? And if he showed all of this, everything would be completely different. I think that it'd be interesting, and I think that it would also be seen as a certain unusual incident, because a person has claimed that he saw this earlier. But it's important to talk about it. If a person saw something earlier and found it earlier and measured it and so on, then why must he be accused of something? Do you agree that what Novoselov and Geim did in particular is a sort of step into the future? Did you see that step? I'm an experimenter. It's possible to find out what specific experiments were carried out and what outstanding results were attained. Just now, the respected professor told us that the prize was given for the outstanding contribution in the investigation of these materials and the finding of new phenomena and effects of these materials. That's what's new about these effects that were found and that hadn't been found before. I feel that what was carried out was a laboratory assistance work. The electrovolt properties were measured, which we measured on tubes. Nothing else was done. Just a minute, Viktor Ivanovich. What do you need that million for? You are, after all, a wealthy man. Do you need the million, fame, or justice? I have my own million. And you have fame. Justice? What are you looking for? What fame? You saw yesterday's broadcast, when a policeman spoke and told the whole country about fullerenes and nanotubes. The policeman Zubardiv. Have a listen. Let's break for commercials and continue in a few minutes. We're back on the air with our program Open Studio. I'd like to present our new guest in Moscow. I present Vitaly Vladimirovich, Director of the Institute of Hard-Body Physics at the Russian Academy of Sciences, Associate Member of the Academy of Sciences, Doctor of Physical and Mathematical Sciences. Vitaly Vladimirovich, good evening. Good evening. Second, I'd like to read here some posts made on our forum about the statements made over the phone by Mr. Geim, that he's not a clown. Nika, don't confuse a scientist's self-respect with hardiness. I'm not confusing self-respect with hardiness. It's just that when the person says that he's not a clown and that he won't participate in this program, then that means that I'm a clown and that Mr. Petrik is a clown. That much is understandable. But it also means that all of our professors here in Moscow and Petersburg are also clowns. I was offended by that. Let's give you the floor, Valery Timofeyevich. You wanted to respond to Georgy Nikolaevich's request and explain to us and all our viewers what you wanted. I'll explain as briefly as possible. The thing is that so far I've fully consciously avoided using technical terms. But it's utterly impossible to explain what makes graphene unique without technical terms. So I'll list those qualities briefly. First of all, the Dirac spectrum of single-layer graphene, the fricative spectrum of dual-layer graphene, the anomalously high gaps in the quantum magnetic field, Hall's quantum effect, which can be observed confidently all the way to nitric temperature, Hall's fractional effect, and finally chiral electronic systems, which are complex relations between an electron's trajectory movement and its spin.
И, наконец, хиральность электронной системы, то есть сложные соотношения между траекторным движением электрона и его спином.
All of this makes graphene an absolutely unique element or object among the many firm two-dimensional electronic systems, and Geim and Novoselov demonstrated that such properties are observable in this very graphene, and that is why they received their Nobel Prize.
И вот Гейм с Новоселовым именно и продемонстрировали, что подобные свойства наблюдаются в этом самом графене.
Простите, можно я задам вопрос?
Pardon me, may I ask a question? I haven't finished yet. Let me say a bit more.
Значит,
Moreover, take a look. Such a step could be taken only by a student of our former Soviet or Russian School of Science for the following reason.
только воспитанники нашей бывшей советской или российской школы научной.
In order to do it, one must have a high level of theoretical understanding and know how to combine coarse means such as the one propagandized by Mr. Petrick with the subtlest methods of analysis and processing. And all of that was applied by them.
С тончайшими методами анализа и процессинга. И все это и было ими применено.
That's the typical signature of our Russian school.
Почерк нашей российской школы.
Yes, please. I have a question. Pardon me, it's just for me, to help me understand. So the work that was carried out, that analytic work, that is undoubtedly very high level, could any of your doctoral students in your institute carry it out?
Проблема, давайте хорошо, раз об этом зашла речь, я еще скажу.
Since you've brought that up, I'll tell you another story. I'll tell the story very briefly and quickly, and all the viewers will be able to understand it. There's a certain famous story about Pyotr Leonidovich Kapitsa. At Cambridge, he got a motor generator. They showed up, and the motor generator didn't work. It had to be sent back to Germany, and that procedure was extremely expensive. He came to an agreement with that company that he would fix that motor generator himself. After that agreement had been signed, he took a sledgehammer, struck the bearings, and the motor generator started working. The sly company men said, "All right, we'll pay you, but present us with a calculation of the work you carried out." He wrote, "One strike with a sledgehammer, 2 pounds. And for knowing where to hit, 1,998 pounds." And so Gaiman Novoselov, unlike the candidate we're discussing, knew where to hit. Please, pardon me, I'll repeat my question. In the example in which our carbonaceous sheet, our two-dimensional carbonaceous crystal is already on the table. If it's on the table, then there's nothing you can do with it but throw it away. But I'm addressing my question to you specifically. Any other doctoral candidate, any technically competent physicist could. No, if your graphene is on the table, I'll answer right now. I'm asking you a specific question. Mr. Petrick, you simply don't have a very clear understanding of how that work is done. Graphene has to be put not on the table, but on silicon. I know all of that, my good man, I know. I'm saying that for the audience. Graphene's lying on the table, and you're saying that it should be lying on a silicone substrate. What significant correction did you just make? The following. If it's lying on the table, it can't be manipulated. But if it's lying on a silicon substrate, it can. Could the work carried out by the Nobel group in your institute be done by other people, or does this group have some sort of amazing... At our institute, anything can be done, including this work, but no one had ever thought of where to hit. We still haven't heard Vitaly Vladimirovich. Vitaly Vladimirovich, your views on this problem. There's one thing I'd like to clarify. I understand that there are laureates who received the Nobel Prize, and on December 10th that prize will be awarded to Gaiman Novoselov. There are other scientists, like Viktor Ivanovich, working on the same issue. Perhaps all of them are good for mankind and for science. You can go ahead and set your things up while we listen to what Vitaly Vladimirovich has to say. Valery Timofeyevich made everything clear. Maybe it's necessary to put it in layman's terms. First of all, what he said about graphene spectrum, it's a unique material. It has a whole mass of electrons and 0 holes, which is completely exotic. Don't be afraid, the dryer in our studio is fully functional. Second, the mobility of those electrons and holes is very high, several times, hundreds of times higher than in silicon. which is what all microelectronics run on nowadays. This means that the characteristic frequencies that graphene electronics will run on could be 100 times higher at room temperature, and that's progress. But when you know what to do, then it's true that maybe any well-trained thesis student at our institute could do it. But in order to realize all that has to be done, you need experience, you need luck, you need talent, and they did all that.
Нужно много всего, нужен опыт, нужно везение, нужен талант. Ну вот они все это и сделали.
Dear physicists, can we adorn our meeting today with an experiment? This is done the following way. Here lies a graphene plate. Observe the indicators behind the arrow. You can magnify it. Magnify it, no one can see it. Why tell us? This is another commercial. It's straight up advertising. Why a commercial? I'm watching and trying to understand. I don't see what we're advertising. Alright, turn it off. I'll ask one very simple question. You're advertising, Mr. Petrick. You're a scientist, let me ask you. We know about the foaming of graphite. Why are you showing this to us? What foaming when this is a graphene plate? I'm demonstrating produced energy. Or are you like Kruglikov? I want to ask a question, just a minute. So, before you lie two plates. They produce electric energy. Between them is an electrolyte, although that isn't so. Do you know that the whole team of the Russian Academy of Sciences accepted this device, and 21 academicians signed this document? Here are their signatures. This document says that this work deserves a huge amount of scientific attention. Here are 21 people, all leaders in their field, including 2 vice presidents. Here's my question. Here you have 2 graphene plates. It's impossible to have graphene plates that can be taken in one's hands. Are you afraid of what I'm going to ask next? Listen, you're a well-mannered person. I don't know, I do not presume to qualify how well-mannered a person I am.
Вопрос следующего характера к физику.
I don't understand anything. Why are you afraid of the question? It's a short question. The amount of electromotive force increases in direct proportion to human breath. Explain this. If you breathe on a thermocouple, there will be electromotive force. Everyone knows that. That's how temperature is measured.
Любые два материала, приведенные в контакт, будет термопар.
This thermocouple? Any 2 materials brought into contact will be a thermocouple. There's nothing else to discuss. I want to explain the following. And so it's maintained that these are chemical processes. There's the Arrhenius equation. No one whatsoever is saying that this is a chemical process. This is a typical electromotive force process. And that's not a question that has to be discussed on television. These are 2 graphene plates. You're afraid of this question. What temperature are you talking about? You've been arguing for a long time, and we need to break for commercials, so you won't reach anything. You're showing these things and saying that they're graphene. Can we get back to our conversation on the Nobel Prize? We'll break for commercials and then we'll have very little time to get back to the Nobel Prize. So in a few minutes, please don't get distracted into arguing. And we're back. We really have very little time, just 2 minutes and change. Do you know what surprises me? We have an argument here today, a very serious one, and the audience doesn't always understand the topic of conversation. It's as if television is the only chance you get to converse with each other. Is it possible for you to meet with academicians, converse? I met with the Academy of Sciences, with a group of 8 academicians, and we conversed for 6 hours. Then the second time, 11 people got together, and the third time 21, and they signed that document. 3 days ago, the academician Alexandrov declared to the whole country that they didn't send any document. 3 days ago, and a few days ago, Zakharov declared that regarding graphenes, it's all a very sad business. I was absolutely horrified when I found out how Petrick makes graphenes. He takes a bag of coals from a brazier, the kind used to fry meat, pours that onto a large table, douses it, and sets it on fire. That was said by an academician.
Давайте все-таки, братцы, вспомним, как устроена наука.
How about we remember how science is done, gentlemen? Please, it's my turn to speak. Young man, it's my turn. I'll speak for 3 seconds. Pay attention. A huge amount of money has been paid for me. Documents have been printed. The Commission on Pseudoscience has offered $1 million to expose Petrick as a fraud. The documents have been printed in the press. How much it pays for airtime against me? I thought it was because of the water. Let's listen to Vyacheslav Alexandrovich, because I'm forced to say that no one paid us any money today. Such a shame. Vyacheslav Alexandrovich, please. No one gave us any money for this, it's true. But I'd like to say something about these 2 plates. Contact between 2 inhomogeneous materials, and even on 1 inhomogeneous material, if there's a difference in temperature, will always result in this thermic electromotive force, and you'll say that you have perpetual motion. Will 2 aluminum plates give you that? We could be completely happy for Gaiman and Vasilov if they were Russian scientists. I bid you farewell and let them continue to argue. Thank you and see you tomorrow.
Я с вами прощаюсь, а они пусть спорят дальше. Спасибо, увидимся завтра.